This lesson deals with Supplemental Problem 5.3. You can find this problem in the course ebook in the Chapter 5 Supplemental Problems on page 3. Given this op-amp circuit with a capacitor, C1, and a resistor, R2, and a voltage source, V sub S, which is a function of time, can you find the value of V out as a function of time? I have feedback around the op-amp. The voltage across here is driven to 0. There's no current entering or leaving the op-amp. And if we apply voltage V sub S, the current is going to flow. And the current is going to be the current in a capacitor, which is C dV dt. But what is the voltage across the capacitor? Well, it's this node voltage, V sub S, minus this node voltage of 0. There's V sub S across the capacitor. So the current is going to be C1 dVs dt. And that current comes into the node, nothing leaves to the op-amp, so it all goes up into here. And it creates a drop across this resistor. The voltage is going to be then R2 times C1 dVs dt. Let's solve for V out. The rise in voltage equals the drops around the loop. So the rise in voltage, this is a rise in voltage. It's also a negative drop. Rise in voltage is V out. The drop is minus C1 dVs dt times R2 plus 0. That's this expression right here. Let's put the R2 and C1 together. V out is equal to minus R2 C1 times the derivative of V sub S with respect to t. This is called a differentiator circuit because we're differentiating the input and multiplying it by a scalar. Now, Supplemental Problem 5.1 was called an integrator, and this is, of course, called a differentiator. These perform mathematical operations, and that's really where the word op-amp comes from. It's short for mathematical operations. And this is Supplemental Problem 5.3.